In this tutorial, we're going to look at what proxy objects are and how Hibernate provides proxy objects for us. We'll also understand what the eager and lazy method of fetching is. This is a very important tutorial. This addresses the basics, the fundamentals of how Hibernate works. I wish I could mark a star or something because this is really important. So, okay, let me remove this the generator and collection ID that we had in the previous tutorial. We don't need that for this one. Okay, so we'll go back to the standard JPA annotation. Nothing Hibernate specific here. What we've done is we've defined a join table with the name and the primary key ID. So again, to recap, we have a list of address objects in our user entity, and we are saving that as a separate table. Now here is a question. Say I have this, I have this persisted in the database, and now I need to retrieve this. So how do I do that? I use the same thing. I use a session factory to open a new session. So I've closed this. The earlier session, which I used for saving the user object, is closed. Now after that, I open a new session, and then I do a session dot get. The first parameter is the class name, user details dot class, and then the second parameter is the ID. The ID is 1. And of course, I don't need to define the session again. Now this get I will save in my user object. Of course, I'll initialize it as null, just to make sure that we're starting with this clean slate. This could be any other object, just to prove that this is what is assigned. I'm assigning the value as null. So here it's asking me for the cast, I assume. Yeah, it's returning an object, so I'll have to cast this. Okay, there you go. Now I have the user object here. This will fetch the the results, and it will assign this. There's only one user object which has the primary key of 1, obviously, so it's returning that object. I'm casting it as user details, and I'm assigning it to the user object here. Now here's a question. This user object has a list inside it, right? It has this array list, which is the list of addresses. Now, how would we normally get a list of addresses inside a user object? Say we are not using Hibernate. Okay, so now how would we get the user details? We would run a query and get the user data, and then the second query would be to get the addresses of this user. So I have the user ID as 1. Now what I would do is I would run a query to get all addresses where the user ID is 1. Simple enough. Now if I wanted a particular set of addresses, I could restrict it in the where class, and I could get only those addresses. And if I wanted just the user information, I would just go to the user table and get the user information. Now when I'm doing the session.get here, what is actually getting pulled up? We're getting the user object, right? Now this user object has an array list of addresses. So the question is, does the whole list of addresses get pulled up? If the answer is yes, then another question. Say I have 100 addresses for a particular user. Okay, this user has been traveling all over the world. He or she has addresses by a huge list, and now that user has stayed in all these addresses. Now we have a huge amount of data. Now when I'm pulling up this user information, do all those addresses also get pulled up? If it is yes, then what is the cost? What is the performance impact? Now I wouldn't want all those addresses to get pulled up if I'm only interested in, say, the username. Now why would I want to pull up all the addresses as well? Now to answer this question, we'll have to look at what is called as a fetch strategy. Now Hibernate employs a strategy to solve this problem. Now if you want to use just the user information, you can ask Hibernate not to pull up all the address information. In fact, that is the default behavior of Hibernate, unless you configure it otherwise. Now if I do a session.get of user, it is not pulling up the list of addresses as well, even though the user object has this list of addresses here. If you just access it, if you just look at the state of the user object here, when this gets executed, you will see that the addresses list is not initiated. But however, if you use the getter method here, now say I use the getter method, user dot get list of addresses. Now the moment I use this getter method, that's when Hibernate goes and runs another query to the database and fetches the list of addresses. Now why does it do this way, and how does it do this? The why is fairly simple to answer. Like we've already said, if you're just interested in the user data, say this user has a few other information inside the user details itself, like I don't know, phone number, a few other things, and you want to fetch only that. There's no point in fetching the list of addresses. So you fetch the list of addresses only when you're accessing the list of addresses. So the getter, the first time you use this getter, it would fetch the data. So it is more efficient. It doesn't just pull up all the data that's there and say my user details has 5 such lists like this, and each list has 100 objects inside it. It's going to take forever to get one object. Well, I'm just interested in the name, because it's going to pull all those lists and all the data associated with the list, and that's all going to be in vain if you're not using it. So the why is fairly clear. You use it only, you get it only when you use it. So this kind of strategy is called lazy initialization in Hibernate. So what lazy initialization means, that you do not initialize the entire object. You only initialize the first level variables, the first level member variables of the object, and then you initialize the lists only when you actually access it. So that's lazy. And the opposite of that is eager initialization. You can configure Hibernate to do that as well. When you make the the object use eager initialization, then what you're saying is, hey Hibernate, I don't care how many lists are there, I want you to fetch all the related data. So if there is a list in the user object, get all the values of that list. So this is something that's going to take a lot of resources. It's going to take a lot of time. So we should do this only if we need it. Otherwise, you have to stick to the defaults, which is lazy initialization. So now that we know the why, we'll have a look at how Hibernate does this. And what's going on here? You're calling a getter of this object, and you're saying that when this getter runs, Hibernate pulls out all the values. How is it possible? My getter here is just this return list of addresses. It's just returning a value. This is the only line of code that runs when I call the getter. Now, how can Hibernate get all the values when I'm calling this getter? Well, there's really nothing happening. The way Hibernate does this is by using what's called as a proxy class. Now, what's happening in the proxy class is Hibernate, instead of getting the actual object that you're looking for, it gets you a proxy the first time. It's a dynamic subclass of your actual object. How it works. You do a session.get of the user class. Now what Hibernate does is, instead of giving you this user class directly, which means pulling all the values and then packaging it into this user class and then handing it over to you, instead of doing that, what Hibernate does is it cleverly creates this proxy user class. Okay, this proxy user class is a subclass of the user class, and it has the same methods. Now, what the proxy user class does is, instead of fetching the values and populating it into the object and sending it back to the, as a result of the .get, what it does is it just probably fills in all the first level values. Say a list of addresses it does not get, because it's going to be a huge list. Now it's going to get this proxy user class created, and then it's going to hand you the object of proxy user class, not the actual user class. You wouldn't know because it implements the same methods. Now a get ID would probably have parent.getID call. So whatever code you would write would still work on your object that you've got here. But it's not a pure user class object. It's a proxy user class object. And same thing for get name. Get name would probably do a parent.getName. So when you call a get name, actually your code is getting executed even though it's through this proxy. But since your code is getting executed, you don't have to worry about it. You wouldn't even have to know. You get whatever you call, the method gets executed, which is fine. Now consider this list, the one that we're talking about. We have a get list of addresses. Now instead of pulling up all these values and handing it over to you, you handed a proxy user class which does not have the complete list of addresses. Now let's say you made a call to this get list of addresses. Obviously, since you have the proxy object, you would be making a call to this one, the method of the proxy user class. This method will have code to first fetch the values from the database. So that's the first thing it does. It just executes the query to fetch the records from the database and populate the list of addresses member variable. After it does that, then it does a parent dot get list of addresses. So after it gets all the values, then it calls the parent method. So your getter will run fine, but then what's actually happening is before your getter runs, it pulls up all the values from the database. So this ensures two things. One, you don't have to worry about what object you're getting. Your object that you get is still a user class. It fulfills the user relationship because you're having a subclass here. But since you're having a proxy, it makes a call and gets the records just in time, and it then calls the parent object's method, so that as far as the consumer of the object is concerned, they don't have to worry about whether they've got a proxy or they've got an actual object. Everything works fine, but as far as understanding Hibernate is concerned, this is what's happening behind the scenes. Hibernate is providing a proxy, and then it's returning an instance of the proxy. In order to validate our understanding, let's do a quick check. I will get the size of this list of addresses and I'll print it using a system.out. Okay, now this should return the value of 2 because we're saving 2 addresses. So I have saved the user object, initialized it to null, and I'm doing a session.get, and I'm calling the dot size. So if I run this, what happens is Hibernate is pulling up a proxy object here for the user, and I'm calling the get list of addresses dot size of this proxy object. Now the proxy object, when it sees this get list of addresses, it's going to fetch the values from the database and it's going to print out the size. There you go, the value is 2, which is fine. Now, in order to identify that this is a proxy object and not the actual user object, I'll do a small test here. What I'll do is, before I get the list of addresses, before the proxy object gets the list of addresses and saves it as a member variable, I will do a session dot close. So I'll close off the session before the proxy object gets a chance to get the list of addresses. Now what happens when I access this after the session is closed? Now after the session is closed, the proxy object does not have a session for it to get the list of addresses. So we'll end up with an error. Let's test that out. I execute this. There you go, we get an exception, and the exception is called lazy initialization exception, and it says failed to lazily initialize a collection of a role, and no session or session was closed. So our proxy is not able to get the values because the session has already been closed. So there are two ways to address this problem. If we need the session to be closed, and then we need, there's a possibility that we can access a list after the session is closed, and we want Hibernate to pull up everything, is to go to this, the element collection annotation, where we have defined this to be an element collection. I can configure Hibernate to fetch this collection eagerly. Instead of a lazy, which is a default, I want the fetch type to be eager, in which case whenever I do a get, it's going to fetch all the values. It's not going to wait for the first access in order to fetch it. So I do fetch type, fetch equals, again if I press Control space, I come up with two options. Eager and lazy both are enumerations of the fetch type, so I make it as eager and save, and when I run this again, so the value shows up as 2, because even though the session is closed, the eager configuration that I did there makes sure that it gets the entire object, and even though it's returning with a proxy, now you're not getting the actual object, you're actually getting the proxy, but still you're making the fetch type as eager, so that it fetches all the values. Now, why would it still return a proxy if the fetch type is eager? Because there could be another collection here for which you haven't configured and the fetch type is lazy by default. So in that case, the proxy will fetch only that lazily, and this collection it's going to fetch eager.